How do you build a castle that will last for centuries with only rough stones, primitive tools, and ordinary ropes at your disposal? Imagine a world completely devoid of electric cranes, laser levels, modern measuring instruments, and even the simplest calculation tables. No computers, engineering programs, or ready-made instructions, only experience, intuition, and knowledge passed down from generation to generation. And yet it was in this harsh and at first glance helpless era that people managed to erect grandiose cathedrals and fortresses that still stand today and have survived more than 1,000 years of history. These colossal structures were built without a single modern blueprint, without sophisticated technology, and without the safety measures we are accustomed to. Each stone was fitted by hand, and mistakes could cost lives. Watch the video to the end, and you will learn how medieval craftsmen defied gravity, calculated loads by eye, and transformed ordinary dirt, lime, and stone into eternal monuments of architecture that still amaze us with their strength, beauty, and engineering audacity. First, I will reveal a secret that will change your entire perception of construction. It is important to understand that medieval craftsmen did not begin the construction of any building with the foundation, but with a deep foray into the thicket of the forest. They looked for trees with a special shape that had grown for years under the influence of strong winds. It was these curved trunks that became the ideal basis for future arched vaults and powerful ceilings. You will be surprised, but it was living nature that dictated the shape of future majestic castles. The craftsmen did not simply cut down the forest, they chose the time of felling with precision down to the day. Trees were felled only in the depths of winter, when the sap inside the trunk had completely frozen. This made the wood incredibly dense and protected it from rapid decay in the future. This approach allowed the beams to retain their strength for many centuries in a row. Each log became part of a huge living construction set, assembled by the hands of skilled carpenters. The elements were joined without the use of metal nails, which were too expensive. Instead, the craftsmen used wooden pegs carved from dry, hard oak wood. These spikes were driven into holes and swelled over time due to natural humidity. As a result, the structure became a monolith that could not be dismantled without destroying the wood. The entire frame was held together by a precise calculation of weight distribution and friction. The forest giants became a skeleton onto which heavy stone slabs and roofing were later hung. Without this wooden foundation, no cathedral could withstand the enormous pressure of the arches. Carpenters were the most respected people on the construction site because the lives of everyone else depended on their precision. They knew the character of each tree and knew how to use its flaws as key advantages. It was a true art of co-creation between man and wild, primeval nature. It was in these forest labyrinths that the engineering solutions that would later be called the Gothic style were born. The masters passed on the secrets of wood selection only to the most loyal and capable apprentices of the guild. They believed that wood had a soul and could protect a building from evil spirits and storms. Before installation, each beam underwent a rigorous inspection by the master builder of the construction team. Any defect in the structure of the fibers could lead to the collapse of the entire grandiose structure. The wooden ceilings of medieval halls often amaze the imagination with their complexity and elegance of lines. Huge spans were covered without intermediate supports, which seemed like a real divine miracle to contemporaries. The secret lay in a system of struts and braces that transferred the weight of the roof to thick walls. The craftsmen used the geometry of a triangle to create the most rigid and stable system possible. Each such connection was tested by time and thousands of tons of snow on the roof. We are interested to hear your opinion on such ancient methods of working with wood. What do you think about the durability of buildings constructed without a single steel nail or screw? Write about it in the comments, because your opinion helps us make better videos. Be sure to subscribe to our channel so you don't miss out on unique facts about ancient technologies. We have prepared many more fascinating stories from the lives of medieval craftsmen for you. Medieval carpenters created true masterpieces that still stand today in the old cities of Europe. Their work required not only skill, but also a tremendous responsibility to future generations. Every detail was thought out so that it would serve for hundreds of years without major repairs. It was an era when quality was valued above the speed of construction. People built for eternity, paying no attention to the transience of their own time. In the next chapter, we will move on to the material that made these buildings practically eternal. Stone required a completely different approach and even more sophisticated tools for processing. You will learn how huge rocks were transformed into elegant lacework on the facades of cathedrals. It was a battle between man and hard matter that lasted for decades on every construction site. Prepare to be amazed at how primitive tools created incredible beauty. Want to know the main secret of how soft limestone became as hard as diamond? Each construction project began with a search for a suitable stone deposit in the immediate vicinity of the site. Craftsmen preferred to use local materials to reduce the cost of incredibly expensive transportation. Stonecutters studied the layers of rock, determining which stone would be used for the foundation and which for decoration. This required a deep knowledge of geology, accumulated over centuries of practical observation of nature. Stonecutters used heavy picks and chisels to give the blocks the approximate shape of the future details. Each block was marked with the stamp of the craftsman who was responsible for the quality of the extracted and processed material. It was a system of personal responsibility that guaranteed the absence of hidden cracks inside the stone. Transportation to the site was a separate challenge for the engineering minds of that harsh time. Huge carts with wooden wheels got stuck in the mud under the weight of multi-ton stone monoliths. Sometimes it took several dozen strong oxen and hundreds of workers to transport a single block. On inclines, complex systems of levers and ropes were used to prevent the cart from falling. The entire journey from the quarry to the construction site could take weeks of exhausting travel. Upon arrival, the stones underwent final, delicate finishing under the supervision of the chief architect. Here, fine tools were used to create intricate patterns in the stone. The craftsmen worked in special tents that protected them from the scorching sun or pouring rain. Each detail had to fit perfectly with the adjacent blocks without using excess mortar. This required phenomenal eye measurement and iron endurance from each stone carver. The secret to the durability of the walls lay in the special composition of the mortar, which was prepared directly on site. Limestone was burned in kilns for several days until it turned into powder. It was then mixed with clean river sand, and secret organic components were added. This mortar hardened over decades, becoming stronger and more reliable with each passing year. The walls turned into a single stone monolith capable of withstanding the blows of heavy siege weapons. Great attention was paid to how the stones were laid in the structure of the most massive wall. The outer rows always consisted of the best and hardest stone of perfect shape. The interior space was filled with small rubble and crushed stone and poured with liquid lime mortar for strength. This three-layer construction worked perfectly under compression and was not affected by sudden temperature changes. The craftsmen knew that such a wall would stand for centuries without requiring any additional maintenance. Many modern researchers still argue about the exact composition of those ancient building mixtures. Some claim that egg white or animal blood was added to the mortar for elasticity. Others believe that special herbal decoctions were used to slow down the initial drying process of the lime. However, the main secret remained the strict adherence to the technology passed down from mouth to mouth. No additives could replace the skill of a person who could feel the material with their own hands. What do you think was the secret that allowed these walls to stand for thousands of years without collapsing? Do you believe that ancient craftsmen knew more about stone than modern engineers with computers? Share your thoughts in the comments. It is very important for us to discuss this with you. Your questions help us find the most interesting topics for future historical investigations. Subscribe to stay up to date with the most exciting discoveries about our past. In the next chapter, you will learn how these heavy blocks were lifted to a bird's eye view. We will talk about machines that were powered by human legs and ingenuity. You will see that medieval construction sites were places where the most daring and dangerous technologies were concentrated. Are you ready to learn how the living engines of antiquity worked on the construction of giant cathedrals? This spectacle will definitely not leave you indifferent and will make you look at history in a different way. You definitely haven't heard about this unique mechanical secret in any history textbook. Huge wooden wheels inside which people walked were used to lift multi-ton loads to the height of cathedrals. These devices worked on the principle of a modern treadmill, only on a gigantic scale. A person inside such a drum became a living motor capable of lifting a huge block. The entire mechanism was assembled from oak beams and fastened with leather straps and wedges. Working inside such a wheel was incredibly monotonous and extremely dangerous for the worker's life. The slightest mistake or a slipping foot could cause the wheel to start spinning uncontrollably. The uniqueness of these cranes was that they were assembled and disassembled directly during the construction process. As the walls grew, the crane rose higher and higher, resting on the finished floors. This required carpenters to be able to create rigid structures capable of withstanding the vibration from the mechanisms. The wheels themselves often remained inside the towers of cathedrals forever after the completion of all construction work. To this day, these ancient wooden machines can still be found in some cathedrals in Europe. The lifting of stones was accompanied by a complex system of signals transmitted by bells or whistles. Coordination between the workers at the top and the people in the wheel had to be perfect. The master builder stood on scaffolding and personally directed every movement of the load in the air. Slow and smooth lifting ensured that the stone would not hit the wall and damage the masonry. The whole process resembled a complex technical ballet performed at a great height. In addition to the squirrel wheels, screw jacks and lever systems were used to precisely position the blocks. The stone had to be not only lifted, but also placed on a layer of mortar with hairline precision. For this purpose, special clamps were used, which were inserted into pre-cut grooves in the stone. After installation, the grooves were filled with mortar, and the attachment point became completely invisible to the eye. The craftsmen were proud of their ability to make the joints between the stones virtually invisible. The scaffolding around the cathedrals under construction was a separate engineering marvel of the time. These were entire cities made of wood, encircling the building and reaching high into the sky. Workers spent most of their day on these precarious structures in all weather conditions. The scaffolding was built with enormous strength to support not only the weight of people, but also materials. The carpenters who assembled it used unique joints that only tightened over time. Like if you are impressed by the courage and ingenuity of the builders of the past, imagine yourself in their place, walking inside a wheel at the height of the 50th floor of a modern building. Your support helps us find increasingly rare facts about forgotten technologies of antiquity. Subscribe to the channel so you don't miss new episodes about how the greatness of our civilization was forged. We value every viewer and strive to make our content as high quality and interesting as possible. The wooden mechanisms of the Middle Ages proved their effectiveness over many centuries of active use. They allowed humans to overcome the laws of gravity and erect buildings of incredible beauty and complexity. Each such wheel was a unique work of engineering art of its time. Craftsmen constantly improved their machines, making them more reliable and powerful each time. It was a time when human ingenuity replaced the lack of sophisticated computing devices. In the next chapter, you will learn how craftsmen marked out giant foundations without a single map or compass. We will talk about the geometry of ropes and pegs, which allowed them to build perfectly straight walls. You will see how simple mathematics in the hands of a master became a powerful tool of creation. Are you ready to learn how a simple knot in a rope helped to build perfect right angles? This knowledge will forever change your attitude towards the simple things around us. What you are about to learn will completely change your perception of the work of ancient architects. They did not have paper drawings, printers, or laser rangefinders for accurate measurements. The master's main tool was an ordinary rope with 13 knots tied at equal intervals. This simple object allowed them to build perfect triangles and calculate the most complex proportions of a building. With the help of a rope, the master builders transferred the mathematical laws of the universe directly to the construction site. The marking of the foundation began with determining the main axis of the building relative to the cardinal points. The master drove in the first peg and used the rope to draw a perfect circle on the ground. Using the intersection of the arcs, he found a right angle without any complex mathematical calculations. This method was so accurate that the margin of error over 100 meters was only a couple of centimeters. This result amazes even modern surveyors working with electronic devices. The secret of the harmony of medieval cathedrals lay in the use of sacred proportions and simple numbers. Architects believed that geometry was the language spoken by nature and God themselves. All the dimensions of the building, from the width of the windows to the height of the spires, were interrelated. If one parameter changed, the master automatically recalculated all the other elements of the structure. This created a feeling of incredible unity and integrity in each building they erected. Giant wooden compasses made of 2 long beams were used to create the arches. They were used to draw templates of future arches directly on flat surfaces covered with a thin layer of plaster. These life-size drawings served as a guide for stone carvers for many years. Every detail was checked against these lines to ensure it fit perfectly into the overall structure of the building. A 1-inch error at this stage could have caused the entire arch to collapse. The craftsmen used the so-called golden ratio, which they observed in the structure of plants and shells. They believed that such shapes were the most stable and pleasing to the human eye. That is why the walls of cathedrals do not seem heavy to us, despite their enormous weight of thousands of tons. Geometry allowed the load to be distributed so that the building literally floated above the ground. It was a triumph of pure reason over the rough and unwieldy matter of stone. Rope tools were versatile and did not require complex maintenance in the field. The master always wore his measuring rope on his belt as the main symbol of his high authority. The knots on it were the standard by which all other measuring instruments on the construction site were checked. Any deviation from the standard was severely punished, as it could ruin the work of thousands of people. Accuracy was not only a matter of beauty, but also of basic safety. The marking process often turned into a solemn ritual involving customers and clergy. The first peg was driven into the ground to the singing of psalms and the blessing of senior church officials. People believed that a correctly marked building would stand forever under the protection of heavenly forces. At that moment, the master builder was the main actor on whom the future of the city depended. His knowledge was surrounded by an aura of mystery and deep respect among the townspeople. It is interesting to see how this topic is perceived in different parts of the world, where construction was carried out according to their own rules. Do you agree that simple tools can be more effective than modern complex systems? Write about it in the comments. It is very important for us to know your personal opinion on this issue. Each of your messages helps the channel develop and release new exciting videos. We carefully read all your feedback and try to answer the most interesting questions. In the next chapter, you will learn how they coped with the terrible weather that constantly interfered with construction. We will talk about protecting stone from winter frosts and the destructive effects of heavy rains. You will see what tricks people use to prevent their work from turning to dust in a single winter. Are you ready to learn how ordinary lime and wax saved great architectural monuments? These secrets of material survival in harsh climates are still relevant today. Water has always been the most dangerous and insidious enemy of any medieval builder. Getting into micro cracks in the stone, it expanded when it froze and literally tore the blocks apart from the inside. To prevent this, craftsmen used complex drainage systems to divert water away from the building's foundation. They understood that a dry foundation was the key to ensuring that a wall would stand for hundreds of years. The entire terrain around the construction site was carefully planned to ensure proper drainage of rainwater. The roofs of cathedrals and castles were covered with heavy sheets of lead or specially fired clay tiles. Each sheet was laid overlapping so that not a single drop could seep into the wooden frame. The joints were sealed with a mixture of resin and wax, which remained elastic under any temperature fluctuations. It was a laborious task that required extreme care and precision from the roofers. A leaking roof could cause the main beams to rot in just a few seasons. Draining water from huge roof areas led to the appearance of the famous stone gargoyles. These bizarre creatures were not just decorations, but functional ends of drain pipes. They threw streams of water far beyond the walls, protecting the mortar from being washed out of the joints. Without such spitters, water would have run down the stone, gradually destroying the structure of the masonry and the foundation itself. It was an ingenious combination of aesthetics and practical engineering necessity of the time. The interior rooms of castles often suffered from condensation and dampness due to the enormous thickness of the stone walls. To combat this, The walls were plastered on the inside with a thick layer of lime, which absorbed excess moisture. Fireplaces in the halls were constantly lit, creating the necessary air circulation and maintaining warmth. The windows were closed with heavy shutters and later with expensive stained glass windows that protected the interior from drafts and snow. People learned to live in harmony with the harsh climate by using the physics of stone. Dampness could destroy not only the building, but also the health of the people living inside it. Therefore, the floors were often covered with a thick layer of dry grass or straw, which was changed periodically. This helped to insulate the cold from the ground and absorb moisture brought in on shoes from the street. In wealthy homes, carpets and tapestries were used as an additional layer of insulation. The struggle for dry and warm air was a daily feat for the inhabitants of the Middle Ages. The specific whitewashing of the walls not only decorated the building, but also served as a protective layer against mold. Lime had antiseptic properties, killing mold at the stage of its formation in cracks. Every few years, the whitewash layer was renewed, covering up new damage to the stone surface. This allowed the buildings to look fresh and remain healthy for many generations of residents. Regular maintenance was as much a part of life as the construction itself. Many of the technological techniques of that time seem too simple and even naive to us today. However, it was precisely these techniques that made it possible to preserve Europe's architectural heritage in conditions of constant humidity and cold. Ancient builders possessed phenomenal patience, understanding that nature is stronger than any stone. They did not try to defeat the elements, but sought ways to coexist peacefully with them. We can still see the results of this approach today when visiting ancient castles. Protection from water was just one of the many problems that had to be solved on the construction site. In the next chapter, we will talk about foundations that were built on the most unreliable soils. You will learn how people made heavy towers stand where the ground turned into liquid mud. Are you ready to learn the secret of floating cathedrals built on swamps and riverbanks? These engineering solutions still amaze us with their boldness and simplicity. Have you ever wondered how huge cathedrals don't sink into the soft, wet soil? Many great architectural monuments were built in river valleys, where the soil resembles a liquid sponge. To prevent the building from sinking, builders drove thousands of wooden piles made of alder or oak into the ground. These logs were driven so tightly together that they formed a solid wooden platform under the future walls. It was a titanic task that required the participation of hundreds of strong workers for many months. The piles were driven in using heavy hammers, which were lifted by winches and dropped down. Each blow was accompanied by rhythmic songs, which helped the workers synchronize their efforts. The master craftsman made sure that each pile went into the ground until it hit solid foundation hidden deep beneath the layer of dirt. If even one support was installed incorrectly, the entire building could eventually tilt dangerously. The entire foundation became a single unit, distributing the enormous weight of the masonry across the area. A massive layer of rubble stone, poured with thick lime mortar, was laid over the layer of piles. This transition layer acted as a shock absorber, smoothing out small ground movements and vibrations. Only then did the construction of the main load-bearing walls from the highest quality hewn stone begin. The builders did not rush, allowing the foundation to settle and accept the final load before continuing work. Such patience was an important secret to the success of any grandiose project. Sometimes, to strengthen the soil, they used the bonfire method, where they drove short stakes into the ground and then covered them with rubble. This created a soil reinforcement effect, making it more stable and suitable for light structures. However, cathedrals required only deep piles reaching down to the bedrock. Craftsmen conducted test drilling with long poles to study the composition of the ground beneath their feet. Knowledge of geology was as important a skill as the ability to cut stone. Mistakes in foundation design were fatal and could only become apparent after several decades. The famous Leaning Tower of Pisa is the most well-known example of what happens when the bearing capacity of the soil is miscalculated. In the Middle Ages, there were hundreds of lesser-known buildings that simply collapsed due to foundation subsidence. Craftsmen learned from these disasters, constantly improving methods of strengthening the ground beneath their feet. Every surviving cathedral is a testament to the engineer's victory over the unreliable earth. Do you think modern technology could handle such a task better without the use of concrete? In the next chapter, you will learn how ancient craftsmen created perfect arches that hold weight without a single support. We will talk about keystones and the magic of distributing forces in the space of a Gothic cathedral. Are you ready to find out why these arches have not fallen on the heads of parishioners for many centuries? It will be an exciting journey into the world of theoretical mechanics realized in stone. Medieval construction sites were places where people overcame the impossible with their own hands every day. Every pile driven and every stone laid was part of a grand plan designed to last forever. The craftsmen were not afraid of difficulties because they possessed knowledge proven by generations of their predecessors. It was an era of great achievements, when faith in the result was stronger than fear of failure. We still enjoy the fruits of their incredible labor when we walk through old squares. Building the foundation was the most thankless stage, as the fruits of this labor were hidden underground. Nevertheless, it was here that the future life of the entire architectural ensemble was laid. A master who knew how to work with the earth was valued at his weight in gold in any European kingdom. His advice could save the treasury from wasteful spending and the city from the shame of the destruction of its main temple. In the next chapter, we will rise higher and see how the grandeur of the heavenly vaults was created. The construction of arches and vaults was the most difficult and responsible part of building any cathedral. To do this, carpenters first created a temporary wooden structure called a centering. On this wooden base, masons carefully laid the processed blocks, moving from the edges to the very center. The entire structure was held together by word of honor and temporary supports until the very last moment. This was a period of extreme tension for everyone involved in the roof construction process. The culmination of the work was the installation of the keystone at the highest point of the arch. This wedge-shaped block was literally hammered into place, creating the necessary tension throughout the structure. As soon as the keystone was in place, the arch became a self-supporting system capable of bearing enormous loads. After that, the wooden hoops could be dismantled and moved to the next section of the building under construction. The arches gained their independence from the temporary supports and began to live their own life. The secret of the stability of Gothic arches lay in the correct distribution of weight to the external supports, buttresses. The craftsmen came up with the idea of transferring part of the load outside the main walls using flying arches called flying buttresses. This made it possible to make the walls thin and cut huge windows for stained glass. The building turned into a light stone skeleton, where every detail worked to the limit of its physical capabilities. It was a revolution in architecture that changed the face of European cities forever. The interior of the cathedral was filled with light and air, thanks to this unique system of force distribution. People entering the cathedral often could not understand how such heavy stones could hang above their heads. This created a sense of divine presence in the greatness of the human mind, which had conquered gravity. Gothic architecture became the pinnacle of medieval engineering, which is difficult to surpass even today. Each cathedral was a kind of giant textbook of physics and geometry in stone. The construction of the arches often took many decades, and the masters replaced one another. Each new architect had to thoroughly study the work of his predecessor so as not to upset the balance of forces. Tradition and continuity of knowledge played a decisive role in the success of such large-scale and long-lasting projects. Cathedrals grew slowly, like living organisms, adapting to the landscape and available resources. Each generation of builders contributed to the creation of heavenly beauty. Many of these arches survived fires, wars, and even earthquakes, proving their incredible strength. Modern calculations confirm that the intuitive decisions of medieval craftsmen were mathematically correct. They felt the flow of forces within the stone, as well as we feel the warmth of sunlight. It was a deep, almost mystical knowledge of the laws of matter, transmitted through their fingertips. We are still learning from them the ability to create harmony from rough and cold stone. In the next chapter, we will talk about how the daily life of workers was built behind the walls of cathedrals. You will learn about the daily life, hierarchy, and strict rules within the construction guilds. How did people live who did not come down from the scaffolding for years? It was a special caste, with its own laws and secret signs that only the chosen few understood. Get ready to learn about the inner workings of a great construction project, hidden from the eyes of ordinary passers-by and customers. Life on a medieval construction site was subject to a strict hierarchy reminiscent of a military organization. At the center of it all was the master builder, who had unlimited power over all processes and people. Under his leadership worked journeymen and apprentices who dreamed of one day taking his high position. Each member of the guild swore an oath to keep professional secrets and obey the guild's charter without question. It was a closed community with its own internal courts and rules of honor. The working day began with the first rays of the sun and ended only when it was completely dark. People lived in wooden huts right around the construction site, forming temporary settlements. There were also smithies, dining halls, and warehouses for storing valuable tools and materials. Women and children often helped with the housework, providing for the huge army of builders. It was a small world, completely focused on a single goal, the construction of the temple. To communicate over long distances and convey secret instructions, master builders used a system of signs and symbols. Each stonemason had his own unique mark, which he carved into every block he worked on. This allowed the master builder to easily check the quality of the work and keep accurate records for fair payment. The mark was the pride of the master in his personal signature, left for eternity on the walls of the building. Many of these marks can still be seen on the walls of cathedrals today. The builder's diet was simple but very high in calories to maintain strength for heavy physical labor. The basis of the diet was bread, porridge, vegetables, and, of course, beer, which at that time was safer than water. Meat appeared on the table only on major holidays or after the successful completion of the next stage of work. Shared meals helped to unite the team and created a sense of brotherhood among people of different nationalities. The construction project brought together craftsmen from all over Europe under the banner of craftsmanship. Safety precautions on scaffolding were practically non-existent in our modern understanding of the term. People relied on their agility, the strength of their hands, and the mercy of the heavenly patrons of their difficult profession. Falls from heights were common, and each such case was perceived as a tragic inevitability. Guilds had special mutual aid funds to support the families of comrades who had died or been injured. This was the first form of social insurance for the working professions in history. The secret knowledge of the guilds included not only technical techniques, but also the basics of mathematics and astronomy. The masters knew how to orient a building by the stars and how to calculate complex geometric figures. This knowledge was guarded like the greatest treasure, giving power over matter in the respect of kings. Outsiders were strictly forbidden from entering the drawing workshops under threat of severe punishment. Architecture was the real magic of the time, accessible only to a select few. In the next chapter, we will talk about logistics and how materials were delivered from distant countries. You will learn about the caravans and barges that carried treasures to decorate the great cathedrals of Europe. How was it possible to coordinate deliveries in a world without telephones or fast mail? It was a real battle for resources, requiring strategic thinking and enormous organizational skills. Are you ready to see how the global supply network of the Middle Ages worked?
A merchant's ledger.
Supplying materials for a large construction project was a task comparable in complexity to supplying an entire army on the march. Stone, sand, lime, and wood were required in such enormous quantities that local resources were quickly depleted. Craftsmen had to look for suppliers hundreds of kilometers away from the site of the future cathedral or castle. Coordinating these flows required the architect to have the talent of a great commander and an experienced diplomat. Any delay in delivery could lead to the idleness of thousands of workers and huge losses. Waterways were the main transport artery of the Middle Ages, allowing the heaviest and most voluminous cargoes to be transported. Flat-bottom barges loaded with stone slowly floated down rivers, overcoming rapids and numerous customs posts. If the construction site was far from water, the blocks were reloaded onto massive carts pulled by dozens of sturdy oxen. Land transport was many times more expensive and dangerous due to poor roads and forest robbers. Nevertheless, supply caravans moved continuously throughout the construction season. Lead for roofs and expensive glass for stained glass windows were often brought in from other countries and even across the sea. The guild's trade connections spanned all of Europe, allowing them to obtain the best materials from the most famous deposits. The purchase of such valuables required huge advance payments and clear contracts with merchants and transporters. Errors in calculating the required amount of materials could lead to work stoppages at the most critical stages. The master builder had to be an excellent accountant and know the market prices for everything. Great attention was paid to the quality of the raw materials supplied, which were personally inspected by the master upon receipt. If the stone was too brittle or the wood was too wet, the shipment was ruthlessly sent back to the supplier. The reputation of a quarry or forestry depended on how well their goods met the high standards of cathedral construction. Quality control was the first and most important step in ensuring the durability of the future building. There were simply no compromises when it came to materials at that time. Huge covered warehouses were built on site to store supplies in case of supply disruptions. Here, materials were sorted according to their purpose and degree of readiness for use in masonry or finishing. Dry lime was stored in sealed pits protected from moisture, as its spoilage was an irreparable loss. Wood was left under awnings for months, reaching the necessary condition for carpenters to work with. Order in the warehouses was the key to the smooth and coordinated work of the entire construction team. The delivery of materials was often accompanied by the construction of new roads and bridges, which continued to serve the people even after the construction was completed. The grandiose construction transformed the entire surrounding infrastructure, giving impetus to the development of trade and crafts in the area. The appearance of a cathedral on the map meant the flourishing of the city and an influx of new people and capital. Construction logistics became the driving force behind the economy of the entire region for many decades. We often forget the role these construction projects played in the development of civilization as a whole. It is amazing how, without the internet and telephones, people managed to negotiate deliveries over thousands of kilometers. Letters sent by couriers took weeks to arrive, but agreements were honored with remarkable precision and fidelity to the word. Trust was the basis of all business transactions at that time, because deception quickly became known to all market participants. The system of recommendations and guarantees within the guilds worked more effectively than any modern legal contract. It was a world where a craftsman's good name was his most important and reliable asset. In the final chapter, we will summarize and find out what the true price of these grandiose achievements was. We will talk about the legacy left to us by these nameless geniuses of the past. How does their experience help us today? And what can we learn from people who built eternity with their own hands? This will be the final chord of our journey into the world of medieval technology and human resilience. Prepare for conclusions that may change your view of modern progress. Medieval construction has left us with a legacy of not just beautiful buildings, but a whole philosophy of attitude towards work and materials. These masters proved that the human mind is capable of overcoming any technical limitations of its time. They did not build for immediate gain, but with many generations ahead in mind, putting their heart and soul into every stone. Their experience teaches us patience, attention to detail, and a deep respect for the laws of nature. Today, these principles are more important than ever in our rapidly changing and often superficial world. Every surviving cathedral is an open book on physics, geometry, and managing complex projects without computers. We are still studying how they managed to achieve such incredible acoustics and lighting in their interior spaces. Modern restorers often use the same techniques and mortar compositions to preserve these monuments for the future. The knowledge of the ancients has not become obsolete. It has simply become part of the classics on which our entire culture is based. Studying their methods helps us better understand the origins of our own technological progress. Today's technologies allow us to build faster and higher, but how often do we invest as much meaning and passion in our buildings? The experience of the Middle Ages reminds us that architecture is not only about function and measurements, but also about aesthetics that can uplift the human spirit. The harmony of proportions found by craftsmen with the help of a rope and pegs remains the standard of beauty today. We can use their principles to create a more humane and inspiring urban environment in the future. The lessons of the past are always relevant to those who are willing to listen and learn. As we conclude our journey, we see that the Dark Ages were in fact a time of brilliant insights and technical breakthroughs. The people of that time were not primitive. They simply used different tools to solve the same eternal problems. Their ability to organize colossal construction projects in conditions of resource scarcity is still a source of sincere admiration today. We are the heirs to their will to create and their incredible ability to dream big. May these cathedrals serve as a reminder of what people are capable of when they have a goal and faith. What do you think medieval craftsmen would say if they saw our modern construction sites with robots and cranes? Would they be shocked by our speed or upset by the lack of an individual approach to each brick? These are questions with no clear answer, but they make us think about the direction of our development. Perhaps we should sometimes slow down and remember the quality that has been tested by centuries, not years of warranty. True art is timeless and always finds its way to the viewer's heart. Suggest topics for our future videos in the comments. It is very important for us to know what interests you most. Perhaps you want to learn about the secrets of ancient blacksmiths or how the great bridges of the past were built. We will definitely listen to your requests and prepare the highest quality materials based on your suggestions. Your activity helps the channel grow and reach new heights in creating educational content. Thank you for joining us on this exciting journey through history. We conclude our story about how the Middle Ages were built without modern tools and technology. It was an era of great challenges, to which people found answers that were ingenious in their simplicity and effectiveness. The experience of the masters of the past is not just archival data, but a living source of inspiration for each of us today. We have seen that true greatness is created by hands, mind, and an unwavering will to achieve a goal. Subscribe to our channel to continue discovering the secrets of world history and survival technologies.